Hello and welcome back, fellow path integrators. Today once again with a very cool integral, and what I find cool about this integral is that it looks quite simple in the beginning. Then you take a closer look at it and it turns out to be a bit more thinking work, and then in the end it's quite simple again. So how are we going to solve that? Well, we're going to use substitution. To be more precise, we're going to do a double substitution. So the first substitution that we're going to do is we substitute the e to the power of x, and we call it u. Then we take the derivative of u with respect to x, and of course we get e to the power of x. And from this we can conclude that dx can be written as e to the power of minus x times du. And e to the power of minus x is nothing else than 1 over u, so this is just 1 over u times du. So now let's plug that into the integral. So the integral was e to the power of x divided by e to the power of x plus e to the power of minus x dx, and then we plug in the u, so we get the integral u divided by u plus 1 divided by u times 1 over u times du. And then we draw this 1 over u into the fraction here, and from there we will get that the integral turns out into a u divided by u squared plus 1 times a du, of course. So now the next step would be to do another substitution, and what we're going to substitute now is the function in the denominator of the fraction. So what we're going to do is we say that our new variable z is equal to u squared plus 1. From that we take the derivative, so dz over du is 2 times u, and this means that du can be written as dz over du. So now let's plug that into the integral. So the integral was u over u squared plus 1 du, and now we get like u in the counter divided by z, and then times, here I did a little mistake, this should not be du, this should be 2u, so we get here divided by 2u and times dz. So this u and this u, they cancel each other out, so in the end we will get the integral times 1/2 and over 1 over z dz. And this is quite simple to solve because this is just the natural log of the absolute value of z plus a constant c, of course, and then we just need to plug in. So z was defined as u squared plus 1, so this whole integral becomes the natural log of u squared plus 1 plus the constant, and u squared is just e to the power of x squared, so this is 1/2 times the natural log of e to the power of 2x plus 1 plus the constant c, and this function inside of the absolute value is always positive, so we just can drop the absolute value signs and we can draw the 1/2 into the logarithm as a square root, so our final solution would be the natural log of the square root of e to the power of 2x plus 1 and the whole thing plus a constant. So as you could see, you need to put a little bit of thinking into this with the two substitutions, but in the end it turns out to be quite a cool and simple integral. I hope you liked this video. If so, I would be happy to see a like, maybe comment something if you find out something interesting, and yeah, see you in the next video. Bye!